Hello and welcome to a new video for pre-calculus using Math-UC. We're on lesson 24, which is talking about the graphs of cosecant and secant. So last lesson we learned how to graph sine and cosine. Now we're going to go to the next two trig functions, which is cosecant and secant. And you may be thinking, well, I have no idea what cosecant and secant look like. So our first thing we're going to do is just look and see what does a normal cosecant and a normal secant look like. And I'm going to do that using Desmos, but you can use your TI calculator to do that if that's what you would prefer. So let's see. In order to do cosecant, if you are using Desmos, you can just type CSC and then X. This is what cosecant looks like. Now, if you are on your TI 83 or 84, then there is no cosecant button, which I find very annoying because there wasn't a cosecant button whenever I was in school. You'd think they would have managed to get us a cosecant button at some point in time. So in order to graph this using your TI calculator, by the way, the Inspire has a cosecant button, but if it's a 83 or 84, then what we want to do is say, well, the reciprocal of cosecant is sine, and there is a sine button. So we type in y equals 1 divided by sine x, and that gives us cosecant. So that's just kind of a little frustration we have with graphing on the TI calculator. What you don't want to do is use the sine -1 button, because that is a completely different function. Whenever I do that, see that little green graph there? That is the inverse sine. That's not the same as cosecant. So that's not what we want to do. We want to either use Desmos or the Inspire so that we can type in cosecant and have it work, or if we're on our 83 or 84, we want to do 1 divided by sine. Remember, cosecant and sine go together, secant and cosine go together. It's this weird, like, the C and S's go together, not S and S and C and C. So this is what cosecant looks like. Now, this may look like super weird at first, especially considering what sine looks like, but let's actually graph sine at the same time so that we can maybe notice a connection here. Okay, so our cosecant graph is these red, almost parabola-like parts of it, and you can see that what is happening is repeating. Like, we have this up one, and then we have a down one, and then an up one. And if we scroll out, we'll see, by the way, that this pattern just keeps continuing on and on and on, just alternating up and down, up and down. We also, for these graphs, have vertical asymptotes, and that's where we have kind of an imaginary line that our graph approaches but doesn't cross. So we have one right here at x equals 0. See how the red is going towards it, but even though it looks like it gets really close, it would never actually touch that line. We don't end up being able to plug 0 into cosecant at all, because that would mean that we were dividing by 0. So we have an asymptote at 0. We also have an asymptote at pi, not y. And we have one at 2 pi, and we could actually keep going and find more and more asymptotes. They're happening pi apart. They're actually happening every time that sine crosses the x-axis here, if you look. So multiples of pi is where it's happening. The other thing to note is that these places on sine where we're at the top amplitude or the bottom amplitude, that's where our cosecant graph touches and goes up. What's happening is, because these are reciprocals, cosecant, it's like we take the like hill that we have for sine, and it's like we're flipping it up. But because of the way dividing works, instead of it just being like a little section like this, like an actual just reflection, it actually goes up faster and faster and faster towards those asymptotes. So it's kind of interesting. This is a weird graph. It looks kind of cool. But essentially, if we wanted to graph cosecant without using a calculator, what we'd do is graph sine and then say, okay, I'm going to put asymptotes everywhere that sine is crossing the middle. And I'm going to draw like these parabola kind of looking things from the top and the bottom. The period for cosecant, just like sine, is 2 pi, because the period of our trig functions is how long does it take for us to have every single value one time. And so that means we need an up and a down to make one period. So we have up, down from 0 to 2 pi, up, down from 2 pi to 4 pi. So the period, the amount that it takes for this to repeat is 2 pi. So if I want to graph this on my paper, I'm going to make some asymptotes. Well, so what I like to do is actually draw sine first, and I'm not actually going to go ahead and connect the dots, although that's certainly something you can do. What you could do is have 2 different colors, or you could draw sine like really light with your pencil, or you could do like a dashed line or something, but show that it's kind of a guide. I'm going to draw, for asymptotes, a lot of times we'll make dashed lines to show, like, to give us kind of, they're like guidelines. So here's where my asymptote should be. And then it's going to start from the top and go up towards my asymptotes. And then it's going to start at this bottom and go down. And we could repeat it on the other side if we want to. We basically just need to remember that we've got a pattern that's being followed, right? So every pi, we have an asymptote, and then here at negative pi over 2, it would start at the bottom, right? Because they're alternating. That's a really beautiful U-shaped or N-shaped kind of thing there. This one starts at the top. And goes up. So this is what cosecant looks like. Secant is going to go with cosine. So we can go back to Desmos or whatever we're using to graph, and we can type in SEC for secant. If we're doing this on our calculator, our TI 83 or 84 calculator, we need to do 1 divided by cosine, and I need to get rid of this sign right here. And see, those are the same. But what I want to do is actually compare this to regular cosine for the purposes of like understanding how this is graphed. So see, the same thing is happening. Like if we compare this with what we just had for cosecant and sine, it's just that since cosine is a shift over of sine, secant is a shift over of cosecant. So that's how it is. So here where our cosine graph crosses the middle is where we have some vertical asymptotes. Where we're at our top amplitude or bottom amplitude is where we start our actual curve. So we're going to graph this in a similar way. And just in general, the things that made sine and cosine similar are going to make secant and cosecant similar. So if I do a real quick rough sketch of cosine so that I can use that to make my vertical asymptotes where it's crossing in the middle. And then I'll go ahead and put one over here. So it goes up from here and then down from here. And I could keep going on both sides if I wanted to, but that's what secant looks like. In our graphs that we have to do here, we're going to need to think about the associated trig function, the reciprocal trig function. If we can graph the reciprocal trig function with the shifts and stretches and shrinks and things like that, then we can use our trick of where the middle is, we can draw our asymptotes, and then in between those draw our U-shaped and N-shaped kind of graphs there. So that's one option. The other option is just to throw this into the calculator. Not literally, you can't throw things into your calculator. If you're putting it into your TI calculator though, what we would want to do is say 1 divided by sine, because this is cosecant. It opens parentheses for us, so we put in pi. I don't know why I spelled out pi there. Divide by 4, then make sure you close the parentheses and then put +1, and then you should be able to see what this graph looks like. Now, if I wanted to kind of go through the motion of doing this without the calculator, I'd say, okay, well, what does normal sine look like? And then I'd say, okay, but this is shifted left pi over 4, because inside the parentheses it's the opposite of what we think. So instead of it being right because it's positive, it's actually left. And it's left or right because it's affecting x, which is left or right. So we're shifting left pi over 4 and up 1. Now the way I have this drawn, each of these tick marks would be pi over 2. So pi over 4 is half a tick mark. So we want to move everything over half a tick mark and up 1. So this is going to move up here. This is going to move up here. It's going to move here, here, and here. Oops. So then I'm going to actually go and erase the original sign point so I don't get confused. Hopefully. Is that right? Okay. So now that's what sine looks like. And I could connect those if I wanted to. But here's the thing. What we need from this is where are our asymptotes at? Our asymptotes are where it crosses the middle, because we actually shifted up 1. So it's not going to be where it crosses the x-axis anymore. It's going to be where it crosses our anchor, where we're oscillating around. So we're going to put an asymptote here. And here. And here. Those are beautiful looking vertical asymptotes, right? And I'm going to take this dot and I'm going to go up, not crossing my dotted lines. I don't necessarily do a good job of making them look like they're approaching the dotted lines, but I also don't cross them, and I feel like that's more important personally. It's going to go down from here. And so this would be, this is actually one period of our cosecant graph because we've got an up and a down. It says describe the shift period in translation. For the purposes of math UC, when they say shift, they're talking about a horizontal shift. And when they say translation, they're talking about vertical, even though those two words actually can be used in either situation. So I mention it because in the problems below this, the graphing ones, they're like, hey, write an equation for something that has a shift of this and a translation of this. And so then it matters which one they're talking about. So our horizontal shift is that we shifted left pi over 4. I don't know why I keep trying to spell pi. This has never been an issue before. The period is 2 pi. And it looked to me like in these problems, we don't have very many things affecting how big the period is, which is great because that combined with shifting left or right is what makes these things really complicated. So that's good that we don't have to deal with that here. And then our translation vertically is up 1. Now it says tell where the asymptotes are located. There's two ways that we can approach this. We can either say I'm just going to list some of the asymptotes. So we have an asymptote here, which is at negative pi over 4. We have one here, which would be between pi over 2 and pi, so that would be 3 pi over 4. And we can just be like, okay, that pattern goes on. The other way to do it is to say, okay, I can say where one of the asymptotes is, and then I can say how far apart they are, and I can use basically almost like a miniature equation or expression to say where all the asymptotes are. So to do that, I would pick one asymptote, like maybe negative pi over 4, and I'd say, okay, these asymptotes, since our period is 2 pi, and we have an asymptote halfway, that means there's an asymptote every pi. The distance from here to here is pi. So there's a way we can write that. We can say that negative pi 4 plus or minus pi times n, where n is an integer, is where all the asymptotes are. And so what that means is that you could actually plug in however many numbers you want all day long if you want to, and be able to figure out asymptote after asymptote after just forever. But I don't actually, I forgot to look up how the Math UC workbook has the answers to this. So I guess you'll have to let me know if you want to in the comments below. Which way they want you to write the asymptotes. You don't have to though, it's fine. But that's kind of all the information they're asking us. So I've got a couple more graphs for us to do. and then a couple more examples after that. So let's try 1/2 secant x minus 2. So that 1/2 in front, if this was cosine, would be telling us that our amplitude was 1/2. So secant and cosecant don't really have amplitude in exactly the same way, because it's more that it's the amplitude in this case, or the number in front in this case, would be affecting like how close to the middle we get. Because if we are shrinking in by 1/2, that means that the ups and the downs will be closer by 1/2. And then this minus 2 is a shift down of 2. So if I graph cosine to start off with, cosine normally looks like this. We want to move it in by 1/2, so that's going to make this move and this move and this move. And then I'll get rid of the points. So this is a vertical shrink of 1/2, but then I want to move all the points down 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And so this is what our cosine graph that has a 1/2 in front and a minus 2 at the end. Make sure that if you put it in the calculator, you close the parentheses after the x, because that minus 2 is outside of secant. They would have had to put parentheses around x minus 2 if they wanted it to be inside of secant. So now everywhere that we are in the middle, we're going to put an asymptote. Here and here and here. Okay, and then from this top we're going to go up. Oh. And then from the bottom we're going to go down. So if we're describing the shift, there was no horizontal shift on this one. The period is 2 pi. The period for sine, cosine, secant, and cosecant, but not tangent and cotangent, is 2 pi unless there's a number being multiplied in front of x or divided below x. So like 2x or x over 2, that's what would affect and change the period. But that's not happening here. We do translate, we do go up to, no, not up, JK, down 2, and then the asymptotes, since each of these are pi over 2, would be at negative pi over 2. Since the period is 2 pi, they're still pi apart, so negative pi over 2 plus or minus pi in would be kind of a formula that would give us any asymptote that we want. So that's example 2. Example 3, we're going to do 2 sine of x minus pi over 2, and then use that to help us get our cosecant graph. So this is a shift right pi over 2, because it's the opposite direction we think it is, since it's inside parentheses. This is stretching sine by 2, so normally sine starts here, goes up, comes back, goes down, comes back, but because it's vertically stretched by 2, these 2 points are going to move out. But then we also need to move everything to the right pi over 2. So everything moves to the right 1 tick mark. I'll just change colors here to help. So this point goes here. This one goes here, 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 here. We could go backwards if we wanted to. So these green dots are going to be where sine would be. And then we want to use that. We want to draw asymptotes in the middle, or where it's in the middle. Here and here and here. And then we want to draw up from the top and down from the bottom. That's wrong. That's so wrong. Why did I do that? That one goes down. Follow the pattern. All right. So we shifted right pi over 2. period is still 2 pi. We didn't move up or down, and the asymptotes would be at pi over 2. I didn't put x equals before, but technically it would be x equals, because we're talking about vertical lines here. So it would be x equals pi over 2, because that's where one of our asymptotes is, this one right here. And they're still pi apart, so plus or minus pi in. So that would be how we could write our asymptotes. These next two examples, I have a mistake here, or a difference. This word should be coefficient, because secant and cosecant don't really have amplitudes. So this is where, since we're using the word shift in translation to mean two different things here, even though they actually are considered kind of the same thing to most people, I think. This is the horizontal. For Matthew C, they're using that as horizontal, and translation they're saying is vertical. And just in general, if you're seeing a shift that involves a pi, it's more likely to be horizontal, because since our period is in terms of pi, it's actually harder to shift by 1 or 2 than it is to shift by something like pi over 3, which is kind of weird. Actually, pi over 3 is not a very pleasant thing to shift by, but that's because it's over 3. Okay, so we're writing secant. This coefficient of 4 means, and it's phrased a little differently in the workbook. It says the coefficient of secant or something like that. So they're saying put a 4 in front. Our horizontal shift is pi over 3. So that's going to go inside, and it's going to be the opposite sign, because anything we put inside parentheses in math ends up being part of the super secret opposite society, which means you do the opposite sign. And then our translation of -3/2, that's outside, so it's not the opposite. That -3/2 is not part of the super secret opposite society, so it stays -3/2. And so that would be our answer. Example 5, write the equation for the cosecant with a shift of -3 pi over 2, a coefficient of 1/3, and a translation of 2. Coefficient is a word that we typically mean for the number in front of x. But in this case, in the Matthew C workbook, like I said, I think it says the coefficient of cosecant, so it means the number in front of cosecant. So we'd put 1/3 cosecant, and then inside our parentheses, we have a shift of -3 pi over 2, so that's plus 3 pi over 2, and then a translation of plus 2. So this would be our answer. Also in these lessons, there's more graphing of sine and cosine, and then there's also some questions that give you a graph and ask you to describe. It's asking you to like say the amplitude or the period or the shifts and things like that. It's asking you to describe it in that way. So that's the idea there. Thanks so much for watching. I hope you'll give this video a like, subscribe if you haven't already, and I'll see you in the next video. Bye.